Alright, today's lesson is on solving linear equations. And this is an important topic, and I'll explain why in 1 second. Gotta catch up on my writing. Basically, it's important because it's one of the most basic things you do in algebra, but it leads to other things, such as being able to graph lines, being able to manipulate equations, and then later on we're going to get to things like quadratic equations, things that are in the first degree. But that's not really such a big deal right now. What I want to focus on right now is this expression, 2x plus 3. I want to make sure that we have the same understanding and labeling of all the different things that are going on here. This guy right here, which we use x, and we talked about that can be a, b, a plant. It doesn't matter what it is. The idea is that it's an arbitrary value. We know we call that the variable. And then this guy right here, that is a number that's being multiplied by the variable. It is known as the coefficient. And anytime you have a number inside of an equation, or an expression for that matter, that doesn't have a variable, it's just a number by itself, we call that a constant. And the basic idea behind solving linear equations is get the variable by itself. Meaning get it to one side of the equation where it's all alone, and then you're going to be able to know what it's equal to. So I've written out a number of different problems we can work on together, and see, I have 2, 4, 6, I have 8 different problems to go over real quick. You're going to want to go over a lot more examples out of the book, things you can find online, different resources, because this takes a lot of practice to get good at. But in any case, I have a problem right now that says 7x plus 8 equals 29. Well, we know, I hope you've heard of the term of the reciprocal. The reciprocal is important because any number multiplied by its reciprocal is equal to 1. A reciprocal is simply if 2/3 is a number, its reciprocal is 3/2. If 7 is a number, that's understood to be 7 over 1, 1/7 is its reciprocal. So you can multiply by 1/7 or you can divide by 7. Both are the same operation. So my point being here, if we wanted to get this 7 that's being multiplied by x here and get rid of it, we could divide everything in the equation by 7. And that means every single term that's in the equation, so if there are multiple terms on one side, everything has to be divided by 7. And if we did that, we get this equation. Yuck. Nasty looking. Ugly. Not the way to go. Instead, we have another choice. The idea is basically this. You have two different constants. You have one on the left-hand side of the equation and one on the right-hand side of the equation. So if we were able to get all the constants on the right-hand side, then divide by 7, we'd have our answer laid out for us. So in that regard, if I want to get rid of a positive 8 that's on the left-hand side of the equation, the inverse of positive 8 is a negative 8. So let's add a negative 8 to both sides. Remember, it's an equation is like a scale. If we do one thing to one side, we have to do the same thing to the other side. Now we get 7x is equal to 21, and if we divide by 7, that's a little bit cleaner. We get x is 3. So remember, we used order of operations. We did that on algebraic expressions. You kind of do the opposite of that when it comes to solving equations. You don't go by the PEMDAS. Instead, try and get your constants and your variables all bulked up together, and ultimately you can solve it. So let's take a look at another one. It's very similar. 2x minus 3 equals 9. Well, all my variables are right here. I've got 2 of them when I need just 1, but they're all at least sitting right here. What I really need to do is get that negative 3 to the other side of the equation. I can do that by adding its inverse, which is positive 3, and then dividing both sides by 2. I get x is 6. How does it get harder? Well, you start adding more things to it. This next example is one that has variables on both hand sides of the equation. The last two examples, as you might have seen, we had the x's were only on the left hand side of the equation. Now we have x's on the right and left. So we've got to figure out a way to get our x's on one side and our constants on the other. The easiest thing I can see, especially if we want to, it doesn't matter if we get all our x's on this side or this side, but I think the easiest thing would be to, if we want to consolidate our x's, let's add 3x because it's the inverse of negative 3x to both sides. Now we have negative 2 plus 3 is 1, so we have 1x, which we can just write as x. It's an understood 1 as a coefficient. equals negative 8. And then to get all the constants, if we're going to shoot for our variables on the left-hand side, that means constants to the right. The opposite of 6 is negative 6, negative 14. And basically, other than some distribution, doesn't really get too much complicated in this until we get to fractions. But we're going to do a separate lesson on that, which will actually be the next one in the list. So how is this one I just put up different? Well, it's different in that we have 3 different terms that have x's in them, but 2 of them are on the same side. So in this case, you can simply combine the 4x and the 2x to make 6x. And now you've got a problem that looks very similar to what we had before. We subtract the 3x from both sides. If we got all the variables to the left-hand side, then we're going to take and get our constants to the right. And we can either multiply by 1/3 or divide by 3, but either way, negative 12 times 1/3 is in fact negative 4. What else can we do? Well, we can add, as I just mentioned earlier, distribution. So in this case, we've got a problem like this. You can make the case then that we have to distribute this negative 3 to both terms in these parentheses, making this negative 3x minus 12, because remember that negative sign is going to carry to both terms, equals negative x plus 7. And then we're right back where we were. If you want to add an x to both sides, that will eliminate any variables on the right-hand side of the equation. So if I add one, I'll have negative 2x now. And then I'd have to get rid of a negative 12, I'd have to add 12. So I would have negative 2x equals to 19. Now 19 is not divisible by negative 2. But that's no big deal. That just means our answer is negative 19 over 2. That's an improper fraction. If you wanted to put it into a mixed numeral, you could say that it's negative 9 and 1/2. But neither one is more simplified than the other, so it really doesn't matter which form you put it in, unless it specifically said something in instructions. But generally speaking in math, we don't do that. The next one. Hang in there. We only got a couple more to go. The question is, first of all, what am I distributing here? What I'm really distributing here is understood to be negative 1. So all it's going to do is change the signs of everything inside that parenthesis. Unlike the last one where we consolidated the variables, here we're going to consolidate some constants. And if you see on the left-hand side, we have 6 and a negative 3 on the same side of the equation. So then you simply add them together. If we're going to bring the x's to the left-hand side, and remember, you can always bring them to the right-hand side. That won't change anything. We're going to have negative 4x plus 3 is equal to negative 10. Subtract 3 from both sides, and looks like we're going to get another ugly fraction, but we don't care about that. One thing to be careful of with this one is a negative divided by a negative is a positive. So you get positive 3/4. Those are the only 6 problems that I really wanted to show you, but I wanted to give you a couple more of something you might see down the road. I call these 2 special cases. The first one, this example, is 3x plus x plus 5 equals 4x plus 5. So when you simplify on the left-hand side by combining the variables together, you get 4x plus 5 equals 4x plus 5. Whenever you simplify something, so if I now subtract 4x from both sides, I get 5 equals 5. No matter what I do, I'm going to get a true statement. That is known as the identity function. The identity, also known as the answer is all real numbers, which we write as a capitalized script of R. That's case number 1. The other case is a case where you might have something like negative 2x plus 6 is equal to negative 2x plus 4. Well, when you start by adding 2x to both sides, you get 6 equals 4. Now, no matter what I do with the rest of this equation, 6 is never going to be equal to 4, no matter what. So in that case, we say this is the null set. Never going to have a solution, never will. Alright, till next time.